Hello everyone, myself Chandrasekhar welcoming you all to this beautiful session on thermodynamics, and today I will be going to discuss about entropy, a very beautiful concept of second law of thermodynamics and very important from your examination point of view. Moreover, the understanding of entropy becomes little complicated for so many students. That is the reason I have brought this concept for your better and efficient understanding. So we will be talking about the entropy transfer or the entropy balance equation for a thermodynamic system. All right. So before I start, let me first quickly recall the definition of the entropy. What exactly is the entropy? The entropy is denoted by S. The unit of entropy is Joule per Kelvin, right? Joule per Kelvin. And the entropy of a system measures the randomness or disorderness existing in a particular system. Entropy is a non-conserved property, unlike the energy. Energy can neither be created nor be destroyed, but entropy can be created. Yes, entropy can be generated due to irreversibility associated with a particular process. So more is the entropy of a system, less will be the efficient. The system will be less efficient. So it is always required to decrease the entropy of the system so that the system becomes more and more efficient. Now let us talk about the transfer of entropy from the system to the surrounding or vice versa. Let me tell you, the entropy transfer takes place along with the heat transfer. Why? Because heat is disorganized form of energy. So whenever there is a transfer of heat taking place from the system to the surrounding or vice versa, it will always carry entropy along with it. But there is no entropy transfer with the work transfer because the work is organized form of energy. So other than the heat transfer, the entropy transfer takes place along with the mass transfer. Whenever the mass is entering into the system, it carries the entropy along with it. When the mass is leaving from the system, it will carry entropy away from the system. So these are the two ways through which entropy transfer from the system or to the system will take place. Other than that, as I said, entropy is a non-conserved property. So due to internal irreversibility associated with a process existing in the system, there is entropy generation. And entropy generation is associated only when there is irreversibility in the process. For the reversible process, the generation of entropy will be zero. So these are the three ways through which an entropy transfer is taking place. Alright, so if we write the entropy balance equation, so the entropy transfer takes place S in minus S out, that is along with the heat transfer and along with the mass transfer, plus there is a possibility of generation of entropy in the system because of irreversibility associated with the system, is equal to change in entropy of the system. Entropy is a property, as I said, it is non-conserved property. So we can call it as S2 minus S1 for the system. The unit of each and every term will be Joule per Kelvin. If we write it per unit mass, so we will write S dot in minus S dot out plus S dot generation per unit time is equal to ds by dt for the system. the unit of this expression will become watt per Kelvin. I hope this is clear. There are two terms on the left hand side, entropy transfer as well as entropy generation. The sum of these two terms will be giving you the change in entropy of the system. And now the system can be a closed system or it can be an open system. If the system is a closed system, it means there is no mass transfer takes place. And if there is no mass transfer take place, then entropy transfer will take place only along with the heat transfer. So we can say S in minus S out is only due to heat transfer plus entropy generation is equal to change in entropy of the system. If we write per unit mass, then we can say, so due to heat transfer, the entropy transfer is del Q by T in to out plus entropy generation is equal to change in entropy of the system. If we write per unit time, then it will be delta Q dot by T. Per unit time is represented by dot. S dot generation is equal to ds by dt in the system. This will be the expression and the limit will be from in to out. That is entropy transfer due to heat transfer. But if it is an open system, if the system is an if the system is closed system but it is having steady state, if the system is in steady state, then the change in property with time will be 0. So ds by dt will be 0 for the steady state closed system. So our expression entropy balance equation will become, the entropy balance equation will become integration of del Q dot by T plus S dot generation is equal to 0. This will be the entropy balance equation for a closed and steady system. And now if it is an open system, for an open system, there is a heat transfer taking place. There is a mass transfer also taking place through the system. So the entropy balance equation will be S in minus S out due to heat transfer plus due to mass transfer plus entropy generation is equal to change in entropy in the control volume. Or we can write it as del Q by T, that is entropy transfer due to heat transfer, plus M in S in specific entropy minus M out S out plus S generation is equal to delta S. So this is due to heat transfer and this is along with the mass transfer and this is due to irreversibility associated with the process, and that will give rise to the total change in entropy. If we write per unit time, then it will be del Q by T dot, then M dot in S in minus, it will be plus, minus M dot out S out plus S dot generation is equal to ds by dt. The analysis will be done by using a control volume. So this will be the entropy balance equation for an open system. And if the open system is having the steady flow process, if it is having the steady flow process, then we can say ds by dt in the control volume will be equal to 0. So our expression is del Q dot by T plus and M dot I is equal to M dot out remains constant. Let me write it as M dot plus M dot, then Si in minus S out plus S dot generation is equal to 0. The unit is watt per Kelvin. This is the expression for the steady flow process existing in the open system. So let us try to solve one question based on this concept only. An amount of 100 kilowatt, that is Q dot, of heat is transferred through a wall in steady state. The wall is in steady state and it is only the heat transfer. So we can call it as closed system. There is no mass transfer taking place. One side of the wall is maintained at 127 degrees Celsius. We can call it as 400 Kelvin, T1. The other side of the wall is at 27 degrees Celsius. We can call it as T2. The question is to find out T2 is equal to 300 Kelvin. The question is to find out the entropy generation in watt per Kelvin due to heat transfer through the wall. So because it is a closed system, here the temperature is T1, here the temperature is T2. This is our system. Then heat is entering Q dot in is equal to Q dot only. The same amount of heat is leaving. Q dot out will be same as this only. So if we write the entropy balance equation for a closed system plus steady state, the system is in steady state. So we can say integration of del Q dot by T into out plus S dot generation is equal to 0. So what is entropy entering? Q dot by T1. So can we write it as Q dot by T1 minus entropy leaving, that is equal to Q dot by T2. It is leaving at temperature T2, heat is leaving at temperature T2, plus S dot generation is equal to 0. Do you agree with this expression? So if we put the value, entropy generation is equal to S dot generation is equal to Q dot by T2 minus Q dot by T1, or we can say Q dot, then it will be T1 minus T2 upon T1 into T2. If you put the value, you will get the answer. What is the value of heat transfer? That is 100 kilowatt per unit time. So 100 into 10 to the power 3, it will become what? Then T1 minus T2, 400 minus 300 upon 400 into 300 watt per Kelvin will be the entropy generation rate in the system because of the heat transfer. Because heat transfer is irreversible process. That is why entropy generation is non-zero. It is irreversible process. So these type of questions are frequently asked in your GATE examination. I hope you understood the concept. So that is all from my side for the day. Take care. See you in the next such video. Thank you guys. Thank you very much. Jai Hind.